Hey everybody, how are we doing? Jeremiah here, Kayla here, Ali here. We got a lot of questions. Love it. Ali's got a question. Oh man, Hacker Man's going right here. Let me reset Hacker Man. It's just Hacker Man all day long. We got to play music now. I think it's working now. I'm gonna answer. Doing well, Kayla. How are you doing? My hair is all just crazy. And go outside and then decontaminate from the world, the crazy world we live in. Hey Maggie, how's it going? Let's hop over to the main screen. We're gonna answer Jeremiah's question real quick. Then we're gonna hop up to Ali's question. Good to see you, Jeremiah. Good to see you, Maggie. Good to see you, Kayla. Let's hop over. Is Hacker Man working properly right now? Oh, there we go. There we go. Hacker Man's working. Let's go to the main screen. Okay. Oh, Hacker Man's everywhere. Maybe I need to fix that. Let's Jeremiah was wondering about when you look at the distribution and you're doing the distribution of the mean, even if, and I think your variable, which one are you doing? Starting salary, right? I might just do that one. Oh wait, my data set's very small right here. My data set, I was working on stuff last night. Here's the 300 data set. Analyze distribution, and yours is gonna look something like this right here. So when we look at this distribution has outliers, feeling finally caught up. That's awesome. That's what we want to hear. Because just staying with the material is the best way to do it. And so if you're feeling caught up, that's awesome. I moved the camera. I know I moved the camera. I felt it when I turned it on. I moved the camera. So what you're noticing right here is this distribution is, I would say it's skewed. This distribution is, kind of skewed, but not heavily skewed. This distribution is skewed here a little bit. And since it's skewed, we need a sample size of at least 25. Let's go look at those notes real quick. We've got a billion notes open. Since it is skewed, we need a sample size of at least 25. We've got our classic conditions right here. So here's our conditions for it. Let's fix the other thing. Yep. It's not so bad. And so the sample size is at least 25 since it is skewed. At least 25 sample size. And we definitely meet that. We definitely meet the condition of at least 25. So we're good. Even if you call it very skewed, which I don't think it's very skewed. I would not say it's very skewed. I'd say it's skewed. You've got outliers. I mean, you should note that there's some skew. You can see the mean's higher than the median. So yeah, that should definitely be met. Great job, Jeremiah, right there. And Ali had a question. In task 3, in reference that in task 1, we were supposed to use an indicator variable on multiple models. However, in task 1, it just says to create and does not require an indicator variable. So I was just making sure it was okay that I didn't use an indicator variable. Yep. So let's take a look at that. Ali, you're 100% right. Here, I'm going to do a cut in the video. I'm trying to remember this. This makes my life so much easier later. Hey, Jacob, good to see you here. This makes my life so much easier later in the evening when I'm putting in tags. I just go and look for the cuts in the video, and I'm like, oh, thank you, pass Brian. And then I giggle as I see like me talking to myself, and I'm like, I remember that. And then tonight, I'm like already in the future right now watching this. I'm weird. I'm like, okay. Yeah, and then I'm like, Brian, why are you still talking? It's because you're pulling up the assignment right now, because you're bringing up the assignment. You're about to talk about it. That's why you're still just filling the void. Here we go. Assignment loading. Assignment is loaded. Let's take a look at the assignment. Here we go. Yep. Thank you, Ali, for coming here and asking. So I'm going to close out all this. I'm going to close down this, close down that. Okay, here we go. Assignment 9 deals a lot with indicator variables and a few topics we've done before. So the first thing you want to do is load in your library reg class. Loading in library reg class, and this should include equals false. You know what? Include equals false should be fine. It just doesn't, it's going to evaluate it. It's going to evaluate. That's good. Well, thank you, Kayla. I appreciate. Yeah, no, I'm glad that can help out because we talk a lot about different things, so I'm glad this can help out. Because I try to put in as many as I can, and sometimes I put in too many. I think it's finding that right balance between right amount of timestamps and too many timestamps. So executive summary. Here we go. Make a simple linear model. So since this is simple linear, you need to use a quantitative variable. Yeah, I wouldn't use a categorical. We've got the EX2 tips data frame. We're trying to predict tip percentage right here. Let's predict tip percentage. We'll go here and we'll go, well, we shouldn't do the code right here because it won't show the code. Yeah, it won't evaluate it. These chunks have turned off their eval. Oh, awesome. Yeah. The chapter 14, I can't, so we don't send it in the chat because that way I'll mention here in a moment, Stephanie. So I don't put the links in the chat lest someone watching the video could go to the playlist, but you should see on the left side of Canvas, the watch live button, and it has the playlist for every lecture. So you should see, because they're unlisted on YouTube, so that way you can go to the watch live button. Here, I'll show it really quick right here. So every class has a watch class live button. So if you're in the asynchronous, you can go to the watch class live button. And they've got the live at because their classes are like, I want them to know what times there are. So anytime, just go to any of these right here, and whatever class you're in, you should see a watch class live button that'll bring you to a page right here, which will bring you to the playlist. So check that out. If you can't find it, let me know and I'll email it to you. But every class should have a watch class live button, and then that will send you to the playlist with all the lectures. And if you can't find it, let me know. Just email me. So the links, we don't put them out there. So thank you, Stephanie, for asking that. You're welcome, Stephanie. Thank you for asking. I realize it's a lot because our class is a little bit different. And I've had people be like, Brian, I can't find a single lecture on YouTube. And I'm like, because they're out the links. Go to the watch class button. So yeah. I'm going to probably make a video explaining this in the future to be like, when you're, like we talk about it in class, but you could, be getting coffee for a half second and come back and be like, you missed 30 seconds or you forget, because it's a different class. So I totally understand. Speaking of coffee, make a simple linear model. LM. I don't want to do it here. If I do it here, everyone will do it here, and then people's code won't work. So I try not to do things that I know in the future will cause problems. I already had that attached, not the end of the world. LM tip percentage. This allows you to autocomplete. So when you use the attach, it takes all these vectors right here, puts them as access to the global environment. So if you don't want to have to always do, and you shouldn't do EX2 tips right here, I don't explain why. Let me show you an issue. Let's use bill and USD. And, data equals y tilde x comma data equals. So that should work, and we can visualize this. So after we finish up, could you go over? Yeah, task 3, you bet. Thank you, Ali. Of course. Object M not found. Oh, I did lowercase m. I never do lowercase m. Why would I do that? I never do that. There we go. If you do the following, which you should not do, don't worry. A lot of people have done this. You'll get this. Don't do that. Y tilde x comma data equals. It's not wrong. You'll still get the summary for this, but the reason is just the way Dr. Petrie's code works. It just doesn't like that format because Dr. Petrie created the visualized model. I am hoping to improve this. I just never have time to go in and redo these things, which I didn't even create it. So I'm taking a car someone built and being like, I'm going to turn this into a hover car. And so I hope to do that. Hope to turn it into a hover car. I want to make some really cool ggplot advancements to it. But, just I got to find time. So this is the simple model here. Any sort of multiple model you create is fine. So you can create any sort of multiple. We'll just call this m.multiple. And so, oh wait, we don't want that. That's all the variables. And now you can run your ANOVA. And we go over if you're stuck on this, please let me know. But there is the ANOVA testing the simple model versus the complex model, where the simple model just has in it bill, the complex model has in it the following. And then we are seeing with the addition of the new variables, which are the new coefficients, which is 8 coefficients. I think one of them 2 level? They're all 2 levels, I think. So there's 8 new coefficients in the model, and they do bring with them new information. We don't really need to talk about the F statistic, but the F statistic shows us that the amount of variation accounted for. So the drop one would not. Well, the drop one does individual partial Fs for each variable in the model. So if you do the drop one, good question right there. We're going to do the drop one m.multiple. And so I wouldn't do the drop one here. Do I say, I don't talk about doing it here. I think I'll talk about doing it later. So the drop one right here, these are actually individual partial Fs, because what it's doing is it's comparing Here we've got our drawing up still, I think, with the partial F. Here we go. So when you're doing this right here, the drop one keeps your full model with everything in it, and then looks at a simple model with just that one variable removed. It looks at your full model with the next variable removed. So each one of these p-values right here, the only one we should really look at right here that is really doing a partial F is which variable. This is a really good getting ahead, which we'll probably be talking about this next lecture, not today, but next week. The only one I really care to look at here that is doing a partial F where it's seeing something is the what? Which one? Which one of these is doing a partial F that is maybe worth looking at? There's only one of these that really is giving us something we wouldn't be getting elsewise. Which variable right here gives us some understanding we didn't have before about that variable. And then KLS. We can create a multiple with just... I would... It's all right if you did that, and I'll explain something here in a second on that, Kale, and then we'll do Ali's question about task 3. Which one of these variables is being looked at in a new way? You can kind of see. It would actually be weekday. The reason weekday is kind of interesting here is because weekday... especially if you remember from yesterday's class, weekday has 4 levels. We've talked about this in today's class if you have class today. Weekday has 4 levels, which does what? Weekday has 4 levels, which does what? Which is the answer to what that is. Since weekday has 4 levels, it's going to do what here? Weekday is going to create what? I'll show you. Weekday is going to create what? And this is what that 3 means. It's going to create 3 indicators. This 3 right here represents the 3 indicators created. And so you know what's really weird about this? Look at the p-value for weekday. It's pretty small. It's not small enough. But look at the p-values for these. Because these p-values are the differences that these days have from what day. So these p-values right here are the differences that these, and this is on the test later, like this understanding, because this is pretty, like understanding what this means, like what do these p-values mean? These are the statistically significant difference that these days have from what? Like these p-values are the statistically significant difference that these days have from what? Friday, exactly, the reference level, which is what the coefficients are, which is what the uncertainty is, the uncertainty and the difference from Friday, and this is the coefficient for the difference from Friday. And it's just arbitrary that it's Friday because it's first alphabetical. So all of these are in reference to Friday. Now here's what the drop one's doing. The drop one is taking that whole thing and doing what to it? What is the drop one doing to all those indicators? It's taking all those indicators and doing what to them with the drop one, which it goes through algorithmically and does it for each one. So it drops 1 for every single one. So it's going to take that weekday variable and just do what to it? And look at, so it's actually doing the partial F because it's going to look at a model with everything in it and then a model without weekday. So it's going to look at a model without weekday and a model with weekday and look at the p-value right here. It removes it, exactly. So the p-value you're seeing is going from a model without weekday to a model with weekday, and it's removing all the coefficients of weekday to do this, and it's seeing if weekday brings with it new information. So this coefficient right here, I mean this variable right here, this variable is telling us, or this p-value, excuse me, this p-value is telling us, does the inclusion of weekday with everything else in the model bring with it new information? And the reason this one's important is because we can just drop one of these, like gender could be dropped. If we go down here to the coefficient of gender male, look at this, boom, 0.4894, and look, 0.4894, because you can remove one thing in and out of the model. One thing can just be removed in and out because it's just a p-value of does that bring new information. So the drop one right here isn't really useful. If we look at size of party, 0.495, I bet you down below it's 0.495. Wait, oh my gosh, it's 0.495. Because these p-values are, does this variable bring with it new significance? But to see if weekday brings with it new significance, we need to take all of weekday and remove all of weekday from the model, which means removing all of the indicators, which is a task for the drop one right here, which does a partial F for each one of them. So the partial F can be used, or the drop one can be used to do partial Fs which are going to tell us the significance of removing like a whole variable from the model. Does that make sense? Why I would use the drop one, especially for categorical variables that have multiple levels? It'll remove out that whole variable and just be like, whoop, and just throws out weekday and says, does weekday bring with it new information if you were to look at a model without weekday and a model with weekday? So it's doing all the work for us of making these models. So hopefully that brings a better understanding of like the partial F and the drop one. Here, we'll head back now. Okay, the next question. Could you go over some tips for task 3? Oh, and then Kayla asked, can we create a multiple with just 2 variables? And so if you create a multiple with 2 variables, if you create a model with 2 variables, Kayla, which you can do, just fine if you do that. What you'll see is the p-value on the partial F test, and tell me if I'm wrong on this, is actually the p-value for the summary on the multiple model. So Kayla, take a look at that. Unless you used an indicator, unless you used an indicator with multiple levels, the p-value for your second variable will be the p-value of the partial F test. Because the partial F test is going to see if going from the simple to the multiple, does the new variable bring information, and the new variable bringing in information could be accounted for by the summary. That's all right, and that you could even mention that in your report. That understanding is important to know that the p-value in a summary tells us if that variable brings information. And so if we look at a 1 variable model going to a 2 variable model, and we do a partial F on that, that'll be the p-value of going. And I put test questions that do theoretical stuff like this, like that understanding that we should have. So hopefully, does that all make sense, Kayla? I'll over here in a second. Like, I'm going to show that really quick because sometimes I realize I can see these things, but I'll show you right here exactly what I'm talking about. Let's go take a 1 variable model. So we'll just call this 1 variable. And let's go here and call this 2 variable. And so we have a 1 variable and 2 variable model. And if we do an ANOVA and we go from the 1 variable to the 2 variable model, we get the following p-value. Well, he says, so it's going to be really hard. So significant. We need to find something less significant so we can actually see the p-value. Size of party. Let's hope that isn't ridiculously significant right now. Good. Not ridiculously. Yep. So it might be hard to see right here. Like the first one would have been size of party doesn't bring with it new information. And so you can see going from the 1 variable to the 2 variable model, size of party doesn't bring with it new information. And so in this summary right here, you can see, and that's rounded, it's the exact same p-value right here that you get right here. Going from the 1 variable model to the 2 variable model, here's the p-value, and here's the same p-value. This is just rounded right there. It's rounded to 0.219. And I hate that they do that, but different output apparently goes by different things. So this p-value right here tells us, does size of party bring with it new information when bill in USD is already in the model? So if bill in USD is already in the model, would putting in size of party bring with it new information? The answer is no. So going from a model with this to a model with this, does it bring new information? The answer is no. And that is encapsulated right here also. So it's the same idea. So really good kind of understanding what the partial F is doing and how each of these p-values right here represents, because we could do the same thing, but reverse the variables, and you'll see the same p-value, but in reverse. So we could put size of party over here, and now we do the same thing, but now the p-value right here is 3.657, which we can see if we go to the 1 variable model. No, we want the 2 variable. That p-value right there is now the p-value we see right here. And I hate that it does that rounding difference. But you'll notice now that the p-value right here is the p-value right here because we're asking, does including bill in USD, going from a model that has this to a model that has this, does bill in USD bring with it new information? Does the complex model bring new information? And that's the same question right here by looking at this variable right here. Does that, hopefully seeing this output, seeing the same p-values right here and right here makes sense. Originally used, either way's fine. We're not trying to solve the world's problems with this. I mean, you can find some pretty good models, and I might do some contests here for the last few to be like, find the best model. Maybe we'll do some bonus for people who find the best models. Like maybe I'll have a form where you submit like your R squared, because we're going to do some model building here soon. We're going to like start if you can tell, our skills are starting to increase, like finding good models and stuff like that. And by the time you get to data mining, we can just like find some really insane stuff. Like the skills you can get in data analytics, like there's so much cool stuff. I'll show you one thing and then this guy, where's he at? Here we go. I gotta mute this. So this guy here is Seth Bling. I think he's a data scientist at Microsoft. And see, I already liked the video. That's the way it goes. He uses neural nets right here to play Mario. And he's using computer programming. He's supposed to use drop 1 for task 1. I wouldn't use drop 1 for task 1. I think later on I suggest maybe using it. I think I have heard of that. Charlie, send me more info on that. I think I have heard of that. You should check out Seth Bling's stuff right here. Did he talked about this is a really cool one where he does like all that. This is one right here, but this has 10 million views. Why have I not liked this video? I gotta be careful. If I put this in the video too much, he could copyright claim us. And I don't, Seth Bling, if you're seeing this, don't copyright claim me. I'm just talking about how awesome you are. I'm not showing your whole video. I'm just explaining how you're using neural nets right here. You're taking in this image and you're using feed forward neural net, I think it is, long short-term memory, goes through all this. And look, so this is, I want to mention this really, there's Seth Bling right there. There's the gentleman, Seth Bling. This right here says sigmoid. Have we talked about anything that's sigmoidal shaped? Have we talked about anything right now that's sigmoidal shaped? Does anyone remember anything we've talked about right now that's sigmoidal? We've talked a little bit about, can't think about Spearman. Spearman can fit a sigmoidal shape because it's going to be monotonic. So he's using a sigmoidal equation. And the reason he's using a sigmoidal equation is because it's bound. This equation cannot go any lower than 1 or -1. We'll use one that goes from 0 to 1. Yep. You can totally create neural nets, and let's just show that really quick. Here we go. So probably one of my favorite packages is Carrot. And so right here, here's Carrot's methods. And we'll go here to neural nets. We'll get all the advertisements. There we go. Dynamic evolving fuzzy inference system, hybrid neural fuzzy, model average neural, monotone multi-layer perceptron. Perceptrons are how neural nets make predictions, or neural network, number of hidden units in layer, learning rate. So you got shrinkage right there, dropout rate, activation function, neural network, another one. All these different things right here. We've got so many different options, just near endless options, tons and tons and tons. Have you seen the ML voice? Is that machine learning voice? Machine learning, right? ML voice synthesizers that people have been training on Clubhouse speakers recordings. Oh my gosh, send me an email with that, John. That sounds crazy. What is it? Like, I know they've made some voice simulators of like people's voices that are like so real that they've had to like remove them. Like they're like, this makes this person's voice and has them say whatever you want. And then people are like, you can't be doing that. You can't be simulating someone's voice so perfectly. And it's like, wow, it's getting pretty crazy. I mean, that just scares me. If God, it's like all this deep fake stuff and all this like voice stuff. So now you could deep fake someone's image and voice task it right there. So John, send info on that, because the way things are going with technology, it's crazy mixed up world. Just like the Aragorn did in Lord of the Rings, the king has returned. What's up, Alexander? We're gonna do a cut in the video, and then we're gonna do Ali's question right here. And good to see you here, John. Hoping the spots in 474 don't fill up before 30 minutes. Join in, Adam. Join in. Okay, Ali's question is, for task 3, I'm stuck on part 3. Write the equation predicting bill based on the weekday. So let's look at the equation right here, which, just to make it clear, Seth Bling was using equations right there. So here's what's really cool, Ali. We don't usually write the equations like, I don't sit down and I write equations, but you have to know the equations. You have to know how these things work. Like, Seth Bling knows how these things work that he's using, but he's not going to sit down and write the equations, but he understands what's going on in the background, which is what we work for. People are recording Clubhouse sessions and using a celebrity's voice to train the machine learning models that are already public available, basically deep fakes, as you mentioned. Yeah, that's what it sounds like to me. That is crazy, John. We've been doing a lot of 320 today. We started off with a little bit of 201. Now we're going to do a little more model building. And this really goes into it, John. This is like how it all starts. This is the genesis of it. Also using it for transcripts for GTP3. What is GTP3 training? Explain what that is, John, while I do this right here. I'm going to make a model. We're going to make a neural net right here. Ansley asks, will you go over the question? Yeah, you bet. Let's do that next right here, Ansley. You got it. So let's go ahead and do that one next. We're going to make a model right here. Ali, I'm going to do like a variation on the model that you'll be doing. Tip in USD. So this might not be your exact model. Brian is not doing your exact work. Okay. Just to make that clear to everyone watching, Brian is not doing your exact work. So Grand Touring Pricks. I don't know what that is. Oh, Alexander's asking because I don't know what that is. We'll find out because I do not know. So I cannot answer the question. Okay, we've got the linear model made. We need to go to the summary. And I think what changed my world was when I used to try to write these, and then I realized the following. I realized all you're doing is going this plus this times this plus this times this plus this times this plus this times this. Top machine learning model for oh, cool. I should learn these things, John. John knows some stuff, right? John, thank you for all the knowledge right there. Yeah, I don't do enough machine learning. Like I teach a little bit of machine learning, but machine learning is a field that's just going like this. It's just, and it's like riding a wave of knowledge. Like people are just like, if you were the best in machine learning 10 years ago, you'd be like, people be like, you know nothing now, because they are constantly growing and evolving. Machine learning, growing and evolving the knowledge in machine learning. Like what we're doing now is, and it's machine learning is intense, and what we can do with computers now. We could build a neural net here earlier today if you guys want. Yes, Ali, great idea. So Friday is missing. So let's start writing the equation right here. So we've got an equation, right? So let's start writing the equation out. Okay, I'm gonna use the double dollar signs, like Vash the Stampede references. And I'm gonna write here tip in USD. So what this does with the double dollar signs is it calls LaTeX code. So this is now LaTeX. So it's going to show the equation. That's so cool. Yeah. Send me info on that, John. That sounds really cool. I may have actually seen some of that because I judged a science fair or the machine learning thing at UT. Dang it, I can't do that. So does this make sense what I'm doing right here, Ali? I'm going to pause right here on this. Is that gonna... Okay, good. Does this make sense? I told my bro to use it. Oh no. John, send me info on this. Send me info on this, John. Soon we'll all just be doing things by computers. Does this make sense what I'm doing right here, Ali? Like what I'm doing right here, does it make sense? I'm going this plus this times this. Exactly. And then we include the indicators also. So I'm going to have to reduce my screen size here a little bit so you can actually see it. And then I'm actually just going to call this Sunday just to make life easier. I might even delete some of the decimals. Doesn't really matter. Tell me if the graders take off. They shouldn't. But as long as everything I'm doing here makes sense, just let me know, because I'm just putting in, and this is, wait, that was Saturday. And after this comes Sunday. And all right, we're just deleting decimals because who needs decimals? Not me. Not me. And Thursday. Okay. So then the question is, and this is why I picked Friday. Friday's not here. Where is Friday? Which I think you know, Ali. I think you know where Friday's at. Where is Friday? Good to hear that, Adam. Glad that went well. Yeah. I think we were talking about it yesterday. Did you include an interaction? Did you include an interaction? If you have an interaction, make sure to include it. You might want to send it to me. Random. Oh, I'll show you here in a second, Brody. I'll show you. We'll do that one next. You got it, Brody. It's the reference level. We're supposed to do an interaction? Sure. With this one? Make a model predicting bill in USD by a party with spent by a party. Oh, no. This one is you are correct, Adam. This one does not include an interaction. Make a model predicting the bill in USD spent by a party from the weekday, Thursday through Sunday, the party visited. Oh yeah. I guess, yeah, maybe an earlier model you might have included an interaction. Explain to the reader what day is missing. So, write the equation for predicting the bill based on the day of the week. What is the predicted bill for Friday? Solve the equation you've written above and give the value. Yeah. We will do some of those. You would just write the same thing out. But now if you're going to, this is a little bit different of a model I've made right here. So this, once again, Brian is not doing your exact work. So exactly, Kayla, you got it. It's just a simple model right here. It's just like, I mean, I'm trying to do not the exact same question, but hint for people watching this part of the video who are watching every bit of this. That's a huge hint. Like that is the model. This is not the model though. It's not the model you're looking for right here. So it's all memes this morning. Can you catch all the memes? Done. So now if we want to make predictions for Friday, what would we do if we want to rewrite this equation here for Friday? If you want to rewrite this equation, don't include party size at all. Adam gets that one. What would you do to rewrite this for Friday? What would you do to rewrite this for Friday? You got it, Ansley. I think it was Brody's will be super quick. Brody's is like, I'll show it and just mention it briefly here. What would you do to rewrite this equation for Friday? $320, do you know? To rewrite this equation for Friday, what would happen to it? Exactly, Kayla. Yep. There we go. And so these all are going to become 0. And since now you would just solve this out mathematically here. And, oh, that's all right, Allie. Allie, don't worry. I'm throwing 50 points out. We got a Mubot. Are you even awake, Mubot? We'll reset Mubot. Mubot's going to crash the world right here. So Mubot destroyed the world. The world is back now. Once Mubot wakes back up, we're going to throw out some points. I think he's been awake this whole time, but sometimes I like just reset him, give him a little, wake him up here, and we'll throw out some points. Does this make sense, Allie? What we did is we put in zeros for all of these right here. I'm not sure is a great answer, and that's where the 100 points. I don't mind when people say I'm not sure. That just lets me know that you're following along, and you're like, I don't know the answer, and then we just work through it. No, we're going to work on it, Alexander, you bet. Add a little spice to Mubot. Exactly. Oh, man, they got spice in Enter the Gungeon. I love Enter the Gungeon. So does this make sense right here, Allie, that we've now written out the equation for Friday, and if we want to write out the equation for Saturday, we would just put a 1 in here and we would solve out, but the other ones would become 0. Does this make sense on how to solve these equations, and then we then reduce this, so you need to then solve everything out? But is this making sense right here, how to make predictions for certain days and write equations for certain days? Like, I think that hopefully will answer the question. Then we're going to quickly do Brody's question. I think I can directly address Brody's, and then we're going to do Ansley's question. Does that make sense? So Friday, you do 0 for all the other weekdays. Correct, because it's the reference level. Each step on involving each. Yeah, I'll have some speedruns out for those, Alexander. Definitely. Categories don't have values, so they're either true or false. Only one day of the week can be true. Exactly, Kayla. Exactly. That's exactly it. We only plug in if you plug in zeros for all of these, then it's Friday, which is the reference level, but you can only plug in like it is Sunday, and then it's not these. So if you look at how this equation changes right here, it's only one of the days of the week. Hey, Roger, good to see you here. And so we've got the equations written out. Let's quickly, here we're going to hop over to space. So Ansley, we will do your question right here after Brody's. Brody's got a really quick question. He was wondering about the conditions. Let's mention the conditions really briefly right here. I've got a report up. Here we go. So just briefly talking about these really quick. So with the conditions, we were talking about the condition 1 is random. The condition 2 is 10%. But then we need to ask ourselves what? What do we do once we do the first few conditions? So what do we do once we do the first few conditions? What do? We go condition 1, random. Condition 2, 10%. And then we pause. And then if it's categorical, which is why I have it shaded green right here, if it's categorical, we do success failure. If it's quantitative, reason I have it blue, we do nearly normal large enough n. This is for chi-squared. This is for chi-squared, hence the similarity in shading of colors. But you can see right here, condition 3 is chi-squared, expected cell count for chi-squared, and condition 4 is count data. If you have two variables, you will go to a fourth condition, which is when you're doing independent means, which is the name of the condition, or count data, which means you have two categorical variables. So we are not doing that for the first one. We are doing the success failure. And for the second one, in the visualization, we are doing nearly normal large enough n. And we show a little bit of that right here. Let's go over and check out. Thank you so much, Ansley's, for waiting for this. Ansley, we will. Oh, I had it right there. Okay, let's head over to space. Ansley, we're doing your question. Ansley, let me get the assignment pulled up. Alexander, stay tuned because we're about to do some chapter 13 and 14. Now, what's good about the end of the semester in 201 is that there's less assignments. There's less assignments at the end of the semester, but you're like, wait, you just don't. Why is there a but here? But the assignments are more difficult. There's less assignments, but the assignments are more difficult. And I mean, I don't want to. It's like if you know how to do something, nothing's difficult. Like I could talk to a theoretical physicist and they'd be like, theoretical physics is super easy. And I'd be like, that's just because you know how to do it. And they'd be like, yes, if you know how to do something, it's not difficult. And I'd be like, well, that's obvious. Let me put it this way. The questions are not too time consuming if you know how to do them, which is the good thing. So the questions are not too time consuming. And I think, let me find, so, which is a good part of it. You're welcome, Brody. Have we discussed how to explain part 5 on task 1 for assignment 9? We might have. We can go back to that here in Roderick in a moment. So we're going to do Ansley's question. Ansley's question was, thank you for waiting, Ansley. Will you go over the question? A sample is randomly chosen from population that can be described as normal. Okay, let's hear. Where is that one? Yep, here we go. Okay, a sample is randomly chosen from a population that can be described as normal. So when we do this right here, we are going to think about what the original shape of the distribution is. The original shape of this distribution is what? The original shape of this distribution, it states, is what? And actually, we might. So the original shape of this distribution is... What is the original shape of the distribution? The original shape of this distribution is normal. Since it is normal, let's go take a look right here. When we take samples from it and we do the distribution of the sample mean, and this is what we're going to be viewing right here. So we have a distribution that is originally normal. Good to see you here, Carson. So we have a distribution that is normal, which is what we are seeing right here. Here's the distribution that is normal. Now, what is the distribution of the sample mean? That means we take how many observations from this distribution and find the what. How many observations is Brian taking from this? You can see it. And then I'm finding the what for those. So Brian is taking how many observations right here and then finding the what for those. Which now, this is now the distribution, and you can read right there what it says. So how many observations am I taking? And then I find the what for those. Man, that would have been so interesting. It was almost very high. It's going to be there. So I'm taking how many observations randomly from this. Condition 1, random. Condition 2, less than 10%. Condition 3, nearly normal. And it's actually going to be for this one down here. So how many observations am I taking? I'm taking the mean for 5 observations. Does that make sense? The mean for 5 observations. And it's easier to see if we do 2 because you can actually see it directly goes between them. Like it's going to, if we get 2 that are a little further apart, you'll see that this blue dot is the mean of that. So you notice how there's 2 black dots, and that blue dot that drops is the mean of the 2 black dots. So you can actually increase this and take the mean of 25 dots. So now the blue dot you see will be the average of those 25 dots, making this distribution down here the distribution of sample means of size 25. So that's a sample mean right here for this random sample of 25 observations, and every single blue dot will be a mean for the distribution of the sample mean, and that's what it is right here. So let's take a look at what happens if we repeatedly do this. It's going to start to build a distribution because we can just see right here, all of these blue dots you're seeing are just the process of just repeatedly doing this, and eventually doing it enough, we'd get something that looks like this. So how does the new distribution look? The original distribution was normal. Good to see you here, Caroline. The original distribution was normal. This distribution down here is also normal, which that didn't narrow it down. But there's a fact that remains. The center of the distribution is going to be the mean. So we can see right here that the original mean for this distribution was 16. The mean for this distribution is also 16. And this is done by the formula. It's a complex formula. The complex formula is the mean for the distribution of the sample mean is equal to the mean, which is stating, it might be the first, let me double check. I'll double check here. The mean for the distribution of the sample mean is the mean, but what do we notice changes right here? What changes is the what. What got smaller? And what's interesting is it got smaller. It was 5, and now it's 1, and we divided it by the square root of 25. So 5 divided by the square root of 25 is 1. So the standard deviation for the distribution of the sample mean is equal to the original standard deviation over the square root of n. So we just take the original standard deviation divided by the square root of n. And so, yep, that would be it right there. If a larger sample is chosen, what is the effect on the distribution? So this is where we need to look at the equation. The center is always mu. So the center is always mu. So the center is going to have what happen to it? The center will remain the same. But what will happen to the variation? And you can see it right here, sigma over square root of n. And you can also see what happens with a small n versus a larger n. The central limit theorem states that the distribution will become more normal and water. What does the central limit theorem state? That it'll become more normal, and it'll also, as n gets larger, become water. You can see it right there, what happened to it as n was larger. And you can see it right here. The standard deviation is going to have this happen to it, and if this gets larger, which of these answers down below is explaining the center won't change because the center is the mean. So what's going to happen to the standard deviation as we increase the sample size? The new standard deviation for the distribution of the sample mean will get water. What will happen? So here's a small sample, and that's what it looks like. And as n gets larger, so what is happening to the standard deviation as n gets larger? It gets smaller. The standard deviation is the variability. So the variability is getting smaller. So because we're dividing by n, so since we're dividing by n, it's going to get smaller and smaller and smaller. So if you look right here with a very small n, here's what it looks like. It's more spread out. And the standard deviation is 3.53. And then if we increase n, well, now it's 1.25 and it got tighter. And if we increase n again, we see right here that it's 1, 1, and it's smaller again. And this is how the mathematics are working, because we are just inputting larger and larger numbers into here. So what outputs out of this when you solve for the new standard deviation of the distribution of the sample mean is going to be a smaller and smaller number. Thank you, Ansley. Great job. This is a good review of the central limit theorem and how it works for the distribution of the sample mean. So the standard deviation will be smaller, but the center will remain the same. Awesome. Who had questions? I think Alexander had some questions. What questions were there? Let's see. And then Roderick had one. Have you discussed how to explain part 5 on task 1? Part 5 on task 1. Yeah, let's go take a look. And Ansley asked more questions. If you have them, let me know. I've got the assignment pulled up right here. We'll cut in the video. Let's go talk about... You're welcome, Ansley. Excellent work. Great job working ahead on these, getting them done. I'm gonna sneeze. Video's all paused. That was me on purpose doing that. Everyone's like, Brian, the video broke. Ah, let's go here. Okay. Let's go take a look. Part 1. Interpret the results of the partial F so that someone who doesn't understand statistics can understand your decision. So for a partial F test, we need to have a simple and a complex model. And we've been making a lot of those today. So we're gonna run a partial F right here. And let's go and make this multi-model. You can call these whatever you want. So I'm gonna call this multi-model. And let's take the multi-model and put it right there, and let's take a look at this. So we're going to go a little more in depth here at the start. I just want speed runs for chapter 13, part 1. I've got some videos up on those, Alexander. I can try to find those here in a moment next. Remind me, and I'll try to send you. Well, let me put a playlist in here right after this, Alexander. Stay tuned. I'll give you a really good playlist to watch that'll help out with a lot of this material. Here we go. So, and can you please explain part 1, task 2? Yep, definitely. So with this right here, how to talk about the partial F. Talking about the partial F, we are taking a simple model versus a complex model. What does a simple model mean? What does a simple model mean? So what does it mean that the model is simple? What does it mean that the model is complex? So when I say a model is simple and a model is complex, what am I meaning with those terms? To say that this is a simple model and this is a complex model, what does that mean? This is simple. What does that mean? This is complex. Model 2 right here is complex. What am I saying by saying model 2 is complex and model 1 is simple? What do those words mean? What's the... and it's kind of, it's so simple is just the idea of less. So think about like you get a simple cheeseburger or you get a complex cheeseburger. Like simple is just going to mean it has less on it. Like a simple cheeseburger might have meat, cheese, onion, ketchup, and mustard or something. Like you just get like a McDonald's cheeseburger, which is very simple. It doesn't mean it just has cheese on it. And maybe you say, well, maybe it should just have cheese on it. Like this one's just a one variable model. But the simple model is going to have less variables in it versus if you go to Five Guys, I just want some Five Guys, and you get like a really complex burger and you just say put everything on it, the complex burger is going to have way more in it. So when you think about simple versus complex, it's just a metric to say complex has more in it. Like you're saying simple has less, complex has more. So we're comparing a smaller model to a larger model. And so what's the point of this? What's the point of comparing these models? Well, the point of comparing these models right here is to see if the models bring with them the variables bring with them new information. Usually our ANOVA goes from a naive model, which a naive has how many variables in it. So simple is relative. Yep. Simple is just relative. It just means less. So your simple has variables in it. The naive model has no variables in it. So the naive model is just the mean of y, which is not really, it's not an x variable. It's, it's using the y to predict y. So makes sense. So this right here is the naive model. Yeah, of course. We got MuBot to help out with that. There you go. Sure, Carson, anytime. You can type ! David and MuBot will help out with that. MuBot, tell everyone where to go. MuBot should put in the chat. Thank you, MuBot, in advance. So thank you, Carson, for asking for that. We're always glad here to help out. And so we have here the simple versus the complex right here. And this is what the partial F is analyzing. So when we do the partial F, we're looking at does going from the simple model to the complex model bring with it new information? And so interactions, which one are you wondering about, John P? If you're going to, I'll try to answer there. So what are you looking at right here? This p-value, what does this p-value mean? And how could we explain this to someone like a boss? So what could we do? What could we say about this? What thoughts are there on this p-value? I mean, it is statistically significant. I think I know what you're saying. So, Roger, what would you say to me about this? What would you tell me about this? What would you be like, you know what that p-value means to me? It is statistically significant. We see right here 8. We don't really need to go into detail about this, but that means there's 8 more coefficients added to the model. Well, size of party was already in there, so it would be these. These are the 1, 2, 3, 4, 5, 6, 7. You might wonder where the other ones are at. There should be 8 coefficient difference. 1, 2, 3, 4, 5, 6. Oh, I see it. 7, 8. There it is. Weekday brings with it 3 indicators. So weekday brings with it 3 indicators. We can view that really quickly right here by going here, and I call this multi-model or something. And there's the 3 indicators by weekday. And remember, size of party was already in there. And the variables that we see right here, was this size of party was already in there? One of those is in there. 1, 2, 3, 4, 5, 6, 7, 8. There's the 8 variables in the new multiple. Because the multiple brings with the new information, I'll use the multiple to help. Yeah, I mean, I think there's good reason to. And this is something we're talking about in 201 lately. We're talking about evidence. There's evidence that the multiple model brings with the new information. So we have evidence to use the multiple model. If we just keep, I think evidence is a good thing to say. Just don't want to say I have good evidence due to the low p-value. That you're not like going into detail about the p-value if you're going to talk to like a boss or something. You're not going to be like, the p-value tells me the probability of my results are more extreme, telling me that the variability or the sums of squared error reduction that we are seeing right here is unlikely due to random chance, and the standardized metric by which we would look at it would be an F statistic, which is almost 80. Plotted on the F distribution, we see a probability of 2. We would just say, we're comparing 2 models right here. We've got this idea of model 1, and we've got this idea of model 2, and we're asking, is there good reason to use model 2? And the answer is there's very good reason to use model 2. So it's not that it's like we maybe should use model 2 with this low of a p-value. Model 2 definitely brings with it new information, or we could say like the ability to predict the variable we're interested in much better than model 1 in a way that is so unlikely due to random chance. Like, we are very, very convinced. Yeah, we got lots of, this is like, we have tons of evidence right here. This is mountains of evidence. And you think about how you'd want to explain that to someone to be like, look, this is not a hunch that this model is better. This is like about as certain as statistics can get. This model is way better. We really need to go with this model. I'm putting all my money on this model. I mean, I could be wrong, but I wouldn't even say I could be wrong because this p-value is ridiculous. Just comparing the 2 models, especially if you look at other metrics for them, I'm as certain statistically as certain can be. This model only explains 2% of the variation, 1.6 after we control for the amount of variables in the model, which it's a simple model. We don't really care about the adjusted. This model explains 73 or 74. The typical miss this model makes is 3.1. The typical miss the model this makes is 6. So the typical miss is half, and we explain 74% of the variation. The first model right here is barely statistically significant. This model down here is ridiculously statistically significant. Going from the simple to the complex model, which is what the partial F analyzes, says that the new variables bring with them information unaccounted for. Then we got Carson question next. The comparison of the 2 models shows me that the second model is better to us for exactly. It brings with it new information. Not that the second model is better. The variables in the second model, I mean, it is that the second model is better, but I would say something about the variables in the second model bring with them new information. Sorry, I might be revising my answer, but I'm always like, I'm doing it on the fly. Like, if you're my boss, I would probably say something. Well, I'd say, well, yeah, it is better, and we really know that the inclusion of these extra variables is important. So going from the model with 1 variable to the model with all the variables, the inclusion of these variables is very, very important. And Carson, I think Roderick has one more question. We're going to put a cut in the video here. So Carson, we got yours next after Roderick had one more question. Thank you, everybody. Great office hours today. So many questions. Roderick was wondering. Oh, no, we're going to do Alexander had the videos. Roderick's other question was, should we discuss the p-value? You could a little bit, Kayla. Not the end of the world. I always want the grades to be a little bit nice, but if you miss something, then you can always debate things. You can always say, like, Brian, why'd I miss this? Or, I think I should get points back. I have given points back to people. Roger, can you explain part 1, task 2? Yeah, there it is. This is part 1, task 2. I'm going to be wondering. Oh, yeah. Let's go right here. Go. Create a new variable and add it to the data frame. Print the head of the column showing only the first 6 observations. So this is where things can go completely crazy. So creating a new variable right here is anything you want. So to create a new variable, you can just do anything. Exactly. Debate. If you lose points, debate it. Be like, hey, Brian, I think I should get my points back. I love debate. I think I think there's a time and place for debate. Like I, you know, I don't know, if someone like came onto the channel, they're like, debate me on this topic, I'd be like, that's not what I do here. I don't debate random topics here. Like I don't, I'm not gonna, it's not my place. It's not what I do. I do statistics is what I do. But like especially like anything. I'm not gonna be debating random topics on this channel. That's not what I do. Because it's I mean, I'll debate it elsewhere in my personal life, hey, we all got opinions, right? And we should be able to, with people who want to engage in such debates. Probably one of my favorite things is people who come to campus and maybe have strong opinions on issues, and then they're out on pedestrian walkway. I miss this Naruto versus DBZ. I've only seen DBZ, and I only know this of Naruto. If you, DBZ, because there's Dragon Ball Z, and then Dragon Ball. What's the other Dragon Balls? I heard there's a new Dragon Ball lately. So I don't know. I can't tell you what I think about Naruto. But what about Bleach? Naruto versus DBZ versus Bleach, and those sound about right, like playing level, like because you're talking like long animes with big story arcs. Probably have to go. Super Dragon Ball Z. Yeah, that's the new one, right? Wasn't there like? I'm thinking of Kakarot, which is his name. I'm thinking of like Vegeta going like Kakarot. He's always getting like mad at Goku. Vegeta and Goku. I like some Dragon Ball Z. Here? Let me tell you. Here's my advice for Dragon Ball Z: watch every other episode, because you'll get like next time on Dragon Ball Z, and it'll give you half the episode, and then don't watch the episode, and then watch the next one, and it'll be like previously on Dragon Ball Z, and it'll give you like everything you missed. So you can usually just like watch every other episode of Dragon Ball Z. That's Brian's advice to catch up on Dragon Ball Z, is just skip every other episode, because it'll tell you about like the next time. Like Goku fights Cell, and Cell transforms into his final form, but not really his final form. It's never their final form. So right here, let's take a look at this. So what we've done in the background here while Brian just talks some anime, that's a good way to distract Brian to talk anime, is we've created a new variable. This variable is the ratio of bill in USD to tip in USD. So, and then what have I done here? What does this line do right here? I think that would save like too much. Yeah, exactly. It's such a long, the Cell Saga. What do you got? You got the Boo Saga. Got a bunch of stuff. What does this line of code do right here, Roderick? What does this line of code do? Can you interpret what Brian's done after dividing the two variables and creating, saving it into X? What does this line of code right here do? What does line of code 117 do? Pretty much. It's creating in the data frame. So in the data frame, I've now stored, my sick kid is watching Sonic X right now. Oh man. As long as it's not, what's that, Sonic Boom? Just don't watch that. Because Sonic's arms are not blue, right? So so many things. So we have ex2 tips, new variable right here, and we're storing X. And so with X right here, this is storing X as new variable into data frame ex2 tips. So we have storing X as new variable into data frame. The creation of the new variable is done right here. So creation of new variable X by dividing two variables. So you can do anything. Yeah, I bet Sonic X is better. Sonic Boom was really bad. The video games were really bad. And then Sonic Generations came out, which was pretty good, which was a throwback to Sega games. Sega. And yeah, we've done it. Does this make sense right here, Roderick? What we've done right here to create the new variable. You can do whatever you want. And we go into more detail yesterday. I'm going to do a few more topics today because we've got like 20 more minutes. I think Office Hours is technically over now, but we're going to do a little more. So hopefully this makes sense right here, Roderick. We've created the new variable. By going right here, you can do whatever you want. I will say this though, a lot of people have done things which I wouldn't do this. If you do something like this, that's just the graphics error. if you do something like this, which Kayla, this Kayla will hopefully make sense. Like other people might make sense too, but we're about to talk some mathematics here. If you were to see this, Kayla, as a matrix, like, tell me, have you done much linear algebra? It's funny, a lot of people don't do linear algebra. If you were to see this right here, what would you tell me about row 3 right there? What would you tell me about row 3? Got row 1, row 2, and row 3. So what would you tell me about row 3 right there? So much linear algebra? Yes. And you can probably see what I quickly did here with row 3 right there, right? Oh, yeah, I'll do it right here. I'll do it right here, Roderick. You got that? So you'll put head of the vector inside of it. You'll go head, vector, comma, and it does 6 by default. I'll show you here next. And so what is the deal with this row, with these other 2 rows? And so that row is a linear combination of the other ones. And so what you'll notice right here, and so head, x, comma. Exactly. Great job, Roderick. Yep. Let's throw some 100 points out there. And thank you so much, Kayla, answering the questions too. Perfect job. So it's a linear combo. Exactly. So it's a linear combination, which means they're not linearly independent. And so we are actually doing the same thing right here, which we could actually, you know what, let's just straight do that right here. Let's just add the 2 variables. So we're literally doing the exact same idea right here. So we literally just took 2 vectors and added them together. Just like old school stuff right there. So now let's take a look. Let's predict tip percentage. Let's do it from bill in USD. Add in here tip in USD and add in here new variable. And as long as I've made the new variable what it is, then what will you see? New variable not found. What? Oh, I know why. I didn't attach it. There we go. Okay. You see this. So this, a few people are running into this issue. It's not, I mean, I guess you could explain this. I would accept it. But what you're seeing right here is that all of the information contained, does this make sense, Kayla, especially in Roderick too, hopefully? Like, but this is very mathematical what's going on. I mean, it's not too mathematical. Roderick, you saw it too, so I don't think this is too complex of a, like, I'm not, it's just that I think Kayla said before she's a mathematics major, so I don't want to be like, other people won't understand this. Like, this goes to the edge of my mathematics understanding. And so if people are like, I don't get it, it's like, don't worry, we don't have to know this big of detail. But then you might have, like, why am I getting this NA right here? It's because all of the information in row 3 is completely what by 1 and 2. Just think about it mathematically, which I'm sure Roderick's getting, I'm sure Kayla's getting it. I want to give everyone props right here. You get, no, you're fine, Roderick. I just don't want everyone to always think like Brian's like, Kayla knows everything. It's just whenever we go to mathematics, I'm always going to go to like the math majors and be like, math majors. They're exactly, Kayla, 100. I mean, Roderick, oh God, I'm done. My brain's over. I need more coffee. Roderick, 100 points. Yep. There is linear dependence here. So this is a linear combination. You've got linear dependence right here. And that's why you see the following in the output is that the new variable I created was just a linear combination, literally like the example I created right there. This new variable is a linear combination of the 2 variables. It does not bring with it any new information. So the model just tosses it back out at us. The model's like, nope, you can take that variable back. I'm not using it because it does not bring with it new information. But if you were to do something like the ratio right here of the 2 variables, so if we were to change this new variable and do the ratio, that would actually create new information. And now when we look at our model, we actually do get, I mean, it's new information that's blah, but it actually can take the variable and use it because it's not a complete linear combination of the other variables. Let me hop to here. that is how we add in some variables. Adding in the variables, we're going to show. Got 10 people watching. That is awesome. Let's go right here. So I want to point something out big. Test 3 review videos. That is Josiah Wilkinson. Let's go ahead and look at this first problem here. I'm Brian Stevens. So here is the playlist. I'm going to put it in the chat here in just a second. Have you thought of a podcast with Lex Freeman? Oh, that's awesome. What does he do? Thank you, John, for all this advice right here. Maybe. So I do know someone at MIT. I have an MIT contact. We actually just published a paper. So I have an MIT contact. And if I don't know it, wait. No, I'm thinking of someone else, Friedman. I'm thinking of the economist. Why can't I think of his name? Milton Friedman? Yeah. Lex Friedman. AI scientist. Oh, this dude's above my pay grade right here. He's going to know some major stuff right here. Looks like he's got a pretty strong Twitter account. Oh, dude, he's got 600K followers. He's got some binary code, working on passing the Turing test. He's got some references to humans or passing. Yeah, wow. He's got a website with his own name on it. Yeah, this guy is top tier. That's why he's at MIT. That is crazy. He's in my second. I've got contacts with him. Wonder if the people I know actually know him. I know a few data scientists who know him or report to know him. They might just like friend it. Yeah. Oh, that is really awesome. Oh, we're doing it right now, Sydney. We probably got just a little bit more time. Anytime I'm live here on YouTube, you can just come in and ask some questions. We were just kind of talking about preparing for the final for a moment here. But I have some videos. They're in the chat right now. I'm going to post this right here. So test 3 review. I'll tell you, if Lex ever wants to do something, we've got the setup right here. I've got different backgrounds and stuff, and I can make different stuff. And I know someone at MIT, so, but he knows his stuff. He knows his stuff. So if you are reviewing for test 3, I go through and talk about, we were talking about this yesterday. So here is doing the steps right here. Exactly. Kayla and Roderick doing a great job. So here's the steps right here we talked about yesterday. We'll be talking about this today in 201, the different steps. And here's the different tests, like doing the t-test. In these videos, I want to point this out really, really quickly right here. Oh, thank you so much, Roderick. I appreciate that. In this video, I go through all the notation and I go through an example problem. So please check out these videos if you're watching this for 201. This is going to be called like 201 test 3 advice. But if you go through these videos and watch a much younger, shorter hair Brian, then you will see all the steps right here for doing the test. You'll see explaining what the test is used for. You will see an example question, all this good stuff here. Short-haired Brian in the background right there. Short-haired Brian looking all crazy like short-haired Brian. So he does robotics, AI, computer science, MIT. He's really popular podcast where he interviews very smart people. Oh, I am honored, John P., that you think I'm very intelligent. And Roderick also made the comment right there that I believe I'm pretty intelligent. I do believe that about myself. But I have met some individuals while teaching who just, I don't want to say scare me. It might not be the right word. But I have met some people while teaching who I'm just like, they fascinate me, I should say. Like, I'm like, you are so intelligent. You learn these things so quickly. Because I've taught some people which I like to think I'm a good educator too. But I've taught some people topics that took me a while to understand, and then they'll understand it like this, and then they'll go and bring new information to me and expand my knowledge. So it's really interesting to teach people, and then they'll go and they'll be like, "Hey, Brian, did you know this about this? And this part of this does this?" And I was like, "Oh, I didn't understand that nuance of it. I didn't know those parts of it." But that's what education is just learning and growing. And if you go back to probably my first year of teaching, My gosh, the knowledge gaps I had, I'm sure there were Grand Canyon gaps, but it really helps to teach the topics because you then can garner a stronger understanding, and then students will come and you kind of see how we learn things. But um, if Lex ever reached out to me, I would be honored to be on his podcast. I hope I could talk about something interesting enough to captivate his audience, because my specialty is definitely not machine learning. Like, he is doing some cutting edge stuff. And John, thank you so much for all the comments today. It could help drive more out of UT traffic to this channel. Yeah, John, definitely. John, I mean, I don't know if you know anyone, or I mean, we always try to reach out in a nice way to people. Gosh, I look dopey right there. Look all confused. Oh, there we go. There we go. Okay, there we go. That's a good scene right there. But yeah, so, and if there's questions right now, let me know. But yeah, really cool stuff right there. Does he have a channel? Let's go check out his channel real quick. You ready? What is his name again? Let me go. Let me go get his name. Let's look at his channel really quick. We'll give him shout outs right here, because he he's not going to need our shout outs. I'm losing my place. Lex Frieden. Okay. There's, whoa. Yeah, he's got 1.2 million subs. 1.2 million. Yeah, there's his podcast. Wow, that's really interesting. That's really cool. So cool channel right here. Check him out. Great stuff. You know what cracks me up is, I think I've had my channel since 2012, and a lot of people, oh, wow. That's an early join date on YouTube. That is early. That is, I'm trying to think when YouTube first started, but that is early. Like, you're rivaling people. Yeah, of course, Roger. Which question do you have, Roger? Feel free to ask. We've just got a little bit of time left. I'm gonna go grab some more coffee before 3:20, right? Whoa, Floshy, he does a bunch of interesting podcasts. Yeah, and look, he's using the exact same microphone we're using. So yeah, he's doing real deal stuff right here. I mean, not that he wouldn't, but this is the Shure SMB7. Looks a little bigger for some reason. That's the Shure SMB7, which is exactly what we're using. No joke. That is the Rode. That is a. He's got the. I'm not. Wait. No joke. Okay, this is just cracking me up. Look, if you look at his podcast thing, this is the exact same arm and everything. This is the exact same microphone, exact same. And I wonder what mixers he's running it through, because he might be running it through exactly what we're doing. And can't tell if that gentleman is in a different studio or where, but that's also a Shure SMB7 with a Rode podcast arm. So cool stuff right there. We did do some of those, Sydney. Which one were you wondering about? We got just a little bit of time right here. Just like prep work and studying for it now, since the data sets states to work, study ahead of time, and test prepare. Yeah. Watch Lex podcast. A lot of it is interpersonal and good banter, but they also talk high tech. Well, I mean, if you wanted to talk about the future of education and things like that, that's probably where I would specialize. I'm definitely not a big enough name. He's looks to be having some pretty high level people right here, and I think I'm decent at banner. I'd hope. We'll talk to some MIT alum I work with. Oh, that's awesome, and see what I can do. Yeah, do you know my email, John? My email is bstevens@utk.edu. Honored to have you here, John. Watch Lex a lot of. Well, yep. Oh, for some reason it doubled that. I have no idea why. A nutrition lab test. Let's put this right here. Let's do it. Okay, Sydney, let's work on this question. So yeah, I could go to a more minimalistic set. That'd be crazy. I mean, he's got a great channel. And thank you for introducing me to that. I'm gonna pull up. So Sydney, we're getting it going right here. We're getting the assignment. Yeah, that'd be game changing, John. Something like that. And I really just think it's crazy. Put it this way: if it happens, I will just be. It'd be. Oh jeez. Oh gosh, I thought I clicked one button. Someone's why I need more coffee. It'd be pretty astounding. It'd be really cool, because he's created a really amazing platform, and I was shocked to see. I'm not there's a lot of new YouTubers who have popped up who have some surprisingly large followings, and they've done it within the last 2-3 years. So I was like, oh, dude, maybe start this 5-6 years ago. Like I started my YouTube channel 8 years ago, and hey, we're at 3,000. I'm proud of that. And but he he started his 15 years ago, and he's definitely put in the work. So great job right there. Let's hop over to the main screen. Let's do this. A nutrition laboratory tests 40 reduced sodium hot dogs and finds a mean sodium content of 310 with a standard deviation of 37. So what do we have here? So Sydney, let's identify the notation on this. Let's identify the notation, and I've grabbed a little bit extra to help out. What notation do we have? What notation do we have right here? And John, also let him know this. If you do reach out to people, I just want to say one last thing on this. Let him know this also, World of Edcraft. I've published with Dr. Andrew Lowe of MIT. We just published a paper called World of Edcraft. Tag it with this here, John. So this is the World of Edcraft paper that we published with Dr. Andrew Lowe of MIT, who was, shout out to Dr. Lowe, one of Time's 2012 People of the Year, Time's 100 2012 People of the Year. So that's Dr. Andrew Lowe at MIT. Dr. Sean Williams and I'm second author. Woo! That was absolute insanity. Like that just blew my mind too. So they probably at least know of each other because they both work at MIT. Well, Dr. Andrew Lowe is at Sloan MIT School of Management, which is 100% MIT still, but they might be in different areas of MIT. I'm sure they know of each other. Like I'd be shocked if they didn't. They're both huge names. But who isn't at MIT, right? So pretty crazy. Okay, let's identify the notation in this problem. Okay. So the notation in this problem is right here. What do we got? Sydney, any of this notation to start. What do we have for this notation in this problem? Any of this notation to get the ball rolling. You're welcome, Cameron. You got it. Hey, Cameron, swing by any time and ask questions on any of them. Whatever you're stuck on. We're working on the sodium content hot dog problem right now. When you're stuck on one, just swing by these office hours or check the videos later with the timestamps. Can you identify any of this notation? We've got here 40 reduced sodium content hot dogs. Finding the mean of the sodium content is 310 for those 40. That's a hint right there. That's for the 40 hot dogs. There was a mean of 310. That's a huge hint. Friedman. Oh, there we go. Totally. I might. I don't know. I might talk to Dr. Lowe and just be like, "Hey, my students were mentioning this. I think are you a student, John?" And then, great job, Cameron. Are you a graduate, John? Are you a student? If as long as you feel open enough to talk about. So, here we go. Here's the notation. That's going to get us the t-score. And then we can get the degrees of freedom. The degrees of freedom are going to be n-1 for the one sample t. And so the degrees of freedom right here are going to be 39. Oh, wait, John, is that yours? Here, I'm gonna hide that, John, so that, and here we go. I think we hit it. So that way, wait, John, I'm gonna, just in case. Oh, wait, here we, I'm just removing for the moment, John. So that way, like, since just with YouTube and stuff, like, I think emails are fine because he has that, like, just in case, because that's an MIT email. I haven't confirmed the number, so I don't know. Like, I'm assuming it probably is, but I'm always like one of these, like, super safe. Does that make sense? Like, I would assume an email that ends in at MIT would go to someone at MIT, but then a number I do not know. So, former student, that's awesome, John. I'm like one of those super precautious people who's like, let's make sure everything. Oh, wait. Oh, that's, yeah, of course I know that name. Good to see you here, Ryan. Totally different name. So, yeah, I do. Wait, you did the machine learning club. Didn't you start the machine learning club? Didn't you? Am I wrong about this? Hence the interest in machine learning. Am I wrong about that? I might be wrong, but you can correct me. So here's where people usually get stuck on this problem. So, and good to see you again, Ryan. Sydney, yes. Sydney, yep. 37 divided by, correct. So everything looks to be on the right track, but the t statistic looks to be a little bit off. So where do we have to go for the t statistic? Where do we have to go for the t statistic? The t statistic, we have to go over here. So for the t statistic, we have to go to this website. So the degrees of freedom are 39. Why are the degrees of freedom 39? The degrees of freedom are 39 because we do n minus 1. Degrees of freedom for a one sample t are n minus 1. So n minus 1, 39 degrees of freedom. And so we go over here to the site. We put in 39 degrees of freedom. We put in 95% confidence, and we make sure we build an interval. So by building the interval, we're going to do this right here. And I think this is where mistakes happen. We need to make sure to use this number right here. So Sydney, that's super close. There, yep, I remember. I was like, I remember that, Ryan, right there. I was like, I do remember. Man, I miss seeing everyone on campus. So this t statistic right here is 2.023. The s is 37. I remember, I think us remember like talking next to the steps when you walk up Haslam. I mean, we talked multiple times, so I just have this memory of that right there. If we were to appear on Lex's show, that'd be insane. You never know. You never know. 37 divided by. So now, but timesing it by this right here will give us the margin of error. That's an error. There we go right there. There's the margin of error, 11.835. So plus or minus 11.835. And that'll be 310 plus or minus. Do you have any questions, Sydney, on how I found any of this right here? Especially the t statistic. Does it make sense how I found everything, including the t statistic? Usually, yeah, supply chain's awesome. Yeah, and thank you, everyone. And if you can tell, like Ryan, is doing supply chain, talking about business analytics, talking about model building. There's a lot of connection between all the topics. We all kind of, nice job, Sydney, nice job. The T is going to be found via the T applet we put in the chat. And this is why the Haslam College of Business is kind of like a synergistic sort of everything. I'm a supply chain business analytics double major. Yeah, that's really awesome, really powerful stuff right there, Roderick. Just understanding how to use all this and like finding the connections between the majors. Then all of a sudden, literally people hire people to do like 2 jobs. It's like, hey, you're gonna, which I mean, like, wait, you want me to do 2 jobs? They're like, but you're very utilized, you're very useful in the company when you have these crossover skills and see the importance of, analytics and supply chain, or how to, do supply chain with analytics. So it's pretty awesome. And I think we've got it right here. So we've got the margin of error, and we've got this. We're just going to add and subtract this number here. Add. Going to add and subtract. And for those who don't know, I am from New York. So there we go, 321.8. And then we're just going to subtract. And 298.2. And what assumptions have we made? Random, 10%. And then we go with nearly normal. So I did very great skill stack, lift analysis. Oh yeah, lift are you talking about market basket analysis, John or Ryan? If you're talking about lift, then you're talking about how it's like Bayesian analytics, because we're talking about priors, like given this is true, how does it impact the probability of this? And that's what we're talking about with lift is Bayesian analytics or Bayesian probabilities, which is, I should say that more often in the class, but it's very important, posterior and prior probabilities. What assumptions have you made? We assume that the hot dogs weights are independent, random, and that the distribution of the population is normal. We don't want multimodal. Should be right. I'm a little worried on that one. Is the randomization condition satisfied? We don't know, but we will assume. I hate this question. Is the 10% condition satisfied? Yes. 40 hot dogs is less than 10% of all hot dogs. Is the nearly normal condition satisfied? We don't know, but since sample size is 40, it's probably okay. It would have to be heavily skewed. Lift can literally be key to making money. Yeah, exactly. Oh gosh, yeah. Because given this, how does it change the probability of this? It's like understanding segments of your audience that do certain things, or your clients. So lift is hugely important. We cover that in 474. We start out with lift, with market basket analysis with A rules package in R. Explain clearly what your interval means. I am 95% confident that the true content of sodium in these hot dogs is contained in the interval blank to blank. Woo, we got 100. Not today, my Pearson, not today. What we are going to do is get some coffee. Make sure to have the interpretation, which I have here on one of these notes. With the interpretation, I am blank percent confident that the true blank is contained in the interval blank to blank. So we were just doing that right here. I am 95% confident that the true mean sodium content of hot dogs is contained in the interval. And then we just go and we give our interval blank to blank. You will see when it does the interpretation some sort of variation on that. They say we are, same thing, blank percent confident that the true blank is contained in the interval. They say the interval contains the true blank. And they don't give the numbers because if they gave the numbers, they would give away the answer to the question. That's why they don't give you the numbers. Things I don't like about this question, what assumptions have you made? It's that we randomly selected that our sample is less than 10% of the population and that we have a nearly normal, or we satisfy the nearly normal large enough N. Yeah, that's awesome, Sydney. That's a big thing where people usually are confused is going to the T-applet and getting the answers. So I think that's got it. Let's head over here. We'll put on a little music. Ryan, we got music now. We got music. We can go back to space. I'd love to talk to him about the future of education, where I see it going, and hopefully, because if education hasn't changed 10 or 20 years from now, which is impossible, you look at what education's done in the last 5-10 years, we'll definitely be lagging behind, and we really need to make it so there's more education for everyone across the world and the US. So, we can focus more on our domestic policy, but we really need to be reaching out and creating just a better global environment. That's one of my goals, is to make education more available. That's why we're just public here on YouTube right now. That's why we do it. And I will say this, let me point this out. No joke. We get people who actually come and, it's not, there's way better educators on YouTube than myself. You got Red Pen, Black Pen, you've got Dr. Leonard, is that his name? But I was really happy. This guy right here looks to be taking stats, and it really made my day that he said, do these videos cover AP curriculum? So I wrote through here's the videos to, for certain units. So I looked up the AP curriculum, and I also looked up some of the questions, and we do stuff like this. This was asking about a cluster analysis right here. And I talked about how in our class, we would see all registered voters within regions we're collected data on. So, some of our videos would help understanding. I beg to differ, Roderick says. So, I really like that our videos are being used by some people. And so I try to help out. But there's way better educators than myself. There's Professor Leonard, who I'm obviously sub to. And 9 years ago, man, he's been on YouTube a long time too. There's Professor Leonard again. You see, I talk about him, and there he is. Professor Leonard, 9 years ago, still doing YouTube, still doing a great job. But with that, I'd like to say thank you, everybody. We will be back. I'm going to go grab some coffee, start teaching some statistics. Bye for now, everyone. Bye.